things running. So during the last exercises, we have implemented this hash table data structure here and started adding some convenience functions. And today we will continue. And the first thing we need will be a rather large assignment, because what we are still missing are iterators. As you might remember from our array, an iterator is not that difficult to implement. It's in principle a type of object which contains some references to our primary data object, like here to the array, and in this case just the index. Of course, that might be a bit more complicated, but our goal here is to implement something similar for our table that allows us to iterate from a given starting point further until the end of the table. For the initial assignment, we really just want to implement the begin and end, and of course the iterator itself. And what we then of course will need later is the find function, but that will be a second assignment for someone else. We can here of course just for convenience copy at least some of it so that we know what we have to do, but not too much, since this will in the end be somewhat different. So this was the table. I just keep the functions as placeholders so that we know what all functions are required, but implementing the content will be the assignment, for which we will need a volunteer. Yes, that looks simple enough. To do later. So, and the table has a typo. So, who would like to implement this iterator now? No one wants to volunteer? Then maybe Mr. Armin?
Okay. Connect.
The current IP address is this one.
Oh, okay.
It changed sometime in December, I think. The rest is the same.
I have a timeout when trying to connect.
You have set the port correctly?
Uh,
6900.
that might be it.
it's still not working.
Done.
That should be working. Now it works.
Okay, I think. Okay. Is it similar to the other one that we've done? Yes.
In principle, yes, there are a few differences. The main differences will be that it's a bit like a combination of an array and a list iterator. Because first you have the array of buckets, so you need some index to point to the right bucket. But then inside each bucket you have like a linked list. So there you need a pointer to next, and then you need some logic to, when you arrive at the end of one linked list, it then skips to the next bucket and then repeats the process. And when skipping to the next bucket, one needs to be careful because the bucket might be null, so not contain any entries. Then it needs to like skip multiple buckets until it finds a valid bucket or the end of the entire table is reached.
So we only have MK index.
In principle, you can define the iterator as a friend of the table, and then give the iterator a whole pointer to the table so that it can access all the functions which the table offers.
A parent of the table?
Friend. I can do that quickly if you give me the mouse. Was it a C iterator or was it no, it was an S iterator, and it was it a class or a struct? It's a struct, and this needs to be consistent, although we don't need to specify it to find the right type. And now if you would give, if the iterator object would have a pointer to the C table, then it is allowed to access all the protected functions like make index, etc., etc.
Don't have bucket item.
We only have the array of buckets and the bucket count. And the bucket item, the type is defined at the very top of the file. Here it is. Well, we have S entry, that's the bucket item, and S table, which represents the content of the current table.
Okay, okay. Yes, we've called it. But our bucket count is not the index, is it?
Well, the index would be 0 until bucket count -1. Bucket count is the amount of entries in the buckets array, and either of them might be set to one entry, a list of entries, or nothing. So our iterator should
Well,
definitely have a pointer to the whole array. It should have a pointer, well, a count, so that it knows how many entries there are. It should have an index that tells it where it is right now. And then what it will need is some pointer to go through the linked list inside. So there are ways to reduce the amount of variables here, but if one wants to keep it as simple and straightforward as possible, then that would be a...
so I'm creating the index in the iterator.
Yes, so the iterator variable, so the iterator object should contain an index which will be then counted through as you ++ through the whole thing. But it should only then be ++ when the current list of the current bucket has been exhausted.
Mm-hmm. How do I select the next bucket? Because
Uh, well, when you do ++ and are inside a bucket and then see that there is no more entries, then you would go to the next bucket.
yeah, but how would
You
I
increment
do
the
that?
index and then just try the next entry in the buckets array.
So I just use this again,
Well,
but that doesn't make sense.
inside, well, that doesn't make sense because as entry is a type and not a
Yeah.
variable.
Well,
I would start at the beginning. Just first thing that you need to implement is the constructor for the iterator. So you can scroll down a bit, stop, yeah, and then here we have our constructor in line 138, where we are creating a new iterator, and there we should think what variables, what data we need to give it on its way so that it can perform its task. So write the
mhm.
variables that we need, and this will be the array of the buckets and the bucket count. And of course the variables should be outside of the function. They need to be in the object itself, and inside the function they will be just assigned by arguments that are passed to the as iterator constructor.
So your bucket count I set to 0, no.
Um, well, the variable should be defined outside the function, obviously, since it needs to be available in all the functions inside this object, like below a friend class table.
Oh, yeah. Okay, okay. Mhm.
And then you add every variable that you want to assign. You add it as an argument to as iterator, and inside the as iterator function you then assign the value of the argument to the value of your variable. So you need
Mhm.
to give them slightly different names. Like for example, at this level you would use m underscore variable name, and as an argument you would just use variable name without m underscore. Then they are nicely differentiated. And since you only have one constructor, you don't need to assign anything um, at the beginning.
Mhm.
Right, so
So,
bucket count, then you need the bucket array, which is of type
oh
as
yeah, of
entry
course.
asterisk.
And then I give them to the iterator you said, right?
Mm-hmm.
Hmm.
And then you can assign them inside the function. Also, it would be good to keep the naming conventions consistent, either all member variables with m underscore or none, like
Oh
mixing
yeah, of
is a
course.
bit
Sorry.
unelegant.
Um, but what values do I assert them to now?
Well, you inside your constructor, you assign the values that you gave as argument to the constructor.
Oh, okay.
And where we get the values from, that will be a thing to think about inside the begin function, which will be creating an object of type um, as iterator.
Can I directly assert bucket array to array?
Yes.
Okay, wait, okay, nice.
Um, Good. So we have our account, we have our array, and then what we will also need will be something to go like within one of the entries to the next and the next. So like a second
Mm-hmm.
S entry um, asterisk, like let's call it M next entry or something like that. Or rather M current entry, because it's the current entry, it's not the next entry. Mm-hmm. And what else do we need? Might already be all. Well, yeah, and we will need an index, which we will need to increment as well. And the index, yeah,
We call M index 2.
capital I, but yes.
Mm-hmm.
Or bucket index to be consistent with the naming. Well, M,
Ah, yeah.
yeah.
Mm-hmm. I just assert the current entry to
Yeah,
the one that I
you already have a variable for an argument for that, so you just set this.
like this.
Hmm.
Okay.
Okay, the next logic step would be to just add, well, implement the assignment operator, since we are using it for the copy constructor. Are we using it for the copy constructor? If we scroll up, up. Yeah.
This one?
Stop. Yes. Here we need to assign those four variables. Just copy them from the other object to the current object.
Mm-hmm. This line we keep?
And we don't have a p-next anywhere, so it needs to go.
Yeah.
And the return is twice, so we only need one
Double,
return.
yeah.
If the warning
Mm-hmm.
level is set high enough, then and treat warning as errors is enabled, then that would not even compile, because it would complain that the second return is an unreachable code, and that is also considered
Mm-hmm. Okay.
an error. Although having unreachable code is also often extremely convenient when debugging something. Just put a return 0 at the beginning of some function, and if the thing then complains and doesn't want to compile, that's annoying. So what I do is
Okay.
I set treat warnings as errors only for the release build, but don't enable it for the debug build. This allows me to debug things quickly, and when I'm
Mm-hmm.
building a release build, I will still get an error thrown if I forget to remove such a
Mm-hmm.
test return or something like that.
Okay.
Right, and here of course we need to assign the values from other, not since this is the only argument we have.
S-
So the index variable doesn't exist in this scope. Only other.bucket index exists. Mm-hmm.
Wait, what?
Yeah, it leaves the standing text standing, so that needs some manual correction. Otherwise, that will not
Ah,
change.
yes, that one. Okay.
Also in
Wait,
index.
wait, no, I have twice. Ah, that's wrong.
Mm-hmm.
Okay. Next one would be
That's it. We only have the 4 variables, right? And then you will need to work on these 2 incremental operators. Um, this is where it gets slightly complicated, because you will need well, since you will
yes,
need
entry is just a type. This won't ever work. Will it
yes, it
work?
will not work. It will not compile.
Yeah. That's-
I would just delete the whole content and then just write it again. Um,
All right. Okay.
I think what would be a convenient approach here, since we have like this function more or less twice, we have like the one that returns itself change and one that returns the value before the change, to outsource the whole plus plus to a dedicated function, which then will be invoked from both operators. This will reduce the amount of redundant code. So you could go to the protected section
Mm-hmm.
and just add the function void increment that will increment the current object. Maybe use a capital I at the beginning of the naming scheme so that we are
Sorry.
consistent with the others. And then you can call this function from above incrementing operators. Too far up.
Yeah, there we go.
From yeah. And here.
Is this line a relic or do we
No,
keep
we
it?
need that because
Okay.
the other type of operator, it returns the value of the iterator before the incrementation happened. So we need to make a copy, then increment,
Mm-hmm.
and then return the copy.
Okay. Do I need to give anything to the increment
No,
or
it just increments by 1.
okay?
The reason why the other function has an int argument is because we want to plus plus variable and variable plus plus to somehow tell them apart, and they decided that one of them will get an unused integer argument for whatever
Mm-hmm.
reason. It's not pretty, but it is what it is.
So I increment now the index.
Well, this is now the complicated part, because so you
Okay.
start off where index points, and at this place you might have an entry in your bucket array,
Mm-hmm.
or the bucket array might have a null entry at this point. And if it has a null entry, then you just increment, and then you increment again, and then you increment again until you find a place where there is an entry. And if you found this place, then you assign this value to the current entry, and
Okay, so I
uh,
need a loop the way you.
you will need a loop, yes. But I said it will be a bit convoluted, because if you call the increment like a subsequent time, then you might be somewhere in the bucket with more than one entry. So then you would like just go with the current entry to the next current entry, and then you're already done. Then you don't change the index. But if you go to the next and the next is null, then you need to increment the index again in a loop. So it's a bit complicated. And also we need one more thing which here isn't yet implemented. When you create the, although this can be done in the begin function. So the thing is, when we create the iterator with just the begin function, which will need to be implemented further down, then we want to be able to already get a value from it. And so if the first bucket already has an entry, this will somehow need to be set and populated, which currently the code is not yet doing. And this can either be part of the next function, or we could implement. Well, we could actually put it in the constructor. That would be probably convenient. Yeah. Yeah. So first you can try to do the increment function. Though I'm thinking if there is like an more elegant solution, because you will need somehow to some of the code will be doubled, because you will need the logic to loop until you find an entry inside your increment, but you will need the same logic inside. Okay, that is maybe a nice workaround. The way this will work is inside of your constructor, or maybe inside of the begin function that will remain to be seen. You will just try to see if the first entry can be assigned, if there is something in the first bucket, and if it is, then it's done. And if there is nothing, then you would then call your increment function, even though you have not retrieved the value yet, because you know that that it's currently pointing to something invalid, and then the increment function will proceed until it finds the next entry, which can be enumerated. So the increment function will need to check. Well, first thing it will need to check is to check if current entry is null or not. And if current entry is not null, then it should try to obtain the next value from the current linked list.
Current entry. Null or
Both are
just the
valid.
value?
Huh. You can use everything. You can use 0, you can write
Okay.
null, or you can use null PTR.
Oh, okay.
Null PTR is the more modern version, and just writing null in capital letters is a preprocessor macro which evaluates directly to the number 0. So it's just optically different, but functionally equivalent.
So null PTR always works?
If you have a new enough compiler, then yes.
Okay.
Older
So
compilers, especially older just C compilers, that's a good question. Would that work in just C? I'm not sure about the specification, because this was introduced for C++. It might be that it only works in C++ files and would not work in a just C file, but I'm not sure about that. Okay, so we know that this is not null. Then we need to advance the linked list. This would be done the same way as it is advanced in the iterator for our list function.
Do we have like a next thing or something here?
No, well, we have a next pointer, but we don't have a function that does the advancing automatically.
Oh, okay. The next points to the next.
Yes.
Okay.
You don't need to cache it. You could just directly assign it.
Okay. Oh, are we just stepping forward then, and are we
Yes.
not overwriting the current one?
No, we are not. We
Ah,
don't want to
okay.
change the the entire table. We only want to step through it.
Wait, what did I do? Why is everything? Oh,
Hmm? Yeah.
okay.
Okay, and now there are two cases that can happen. Either we got the next entry, then we are done, or we got null, meaning this bucket is exhausted and we need to go to the next bucket.
Mm-hmm. So I write two ifs.
I would just write one if current entry now is null, then no, sorry, if current entry is not null, then return, because we got the next entry and then we are done for this invocation of increment.
Is not now,
Hmm.
and we return.
Yeah, and this function in this case would be done. And
Mm-hmm.
if either of those ifs that we already have is false, then we would continue to now looping through the indices until we find the bucket which is not empty and assign the first entry from the bucket to current entry.
So now we need a loop, or
Yes.
uh, does that work?
Nope.
Yeah.
So first of all, we should probably start at the bucket index, and then we should just go until e
Ah.
is less than bucket count. We have already both variables ready to be
Oh yeah, the
used.
count. So what's the goal now?
To find the next bucket which contains something that is not null.
But am I not doing that here already, or do I just copy the code?
Well, that's the point. We have a combination of an array and a linked list. At the top portion, you handle the linked list of the equation. At the bottom portion, you are now handling the array part of the iterator. So here we need to check if the what is it m bucket array at I.
Ah, yeah, 0. Like this, right?
Is yeah. And if we found it, then we need to do something.
Mm-hmm. Which will be the case now, right?
Yes.
Mm.
Well, we need to update the current entry variable on our object, and we will need to set a bucket index such that the next invocation of this function will do the right thing.
Do I also just shift it?
No, you want the first one.
The first one.
Just the m bucket array at I. And the reference on that. And I think you need to to add the reference operator at the beginning of this thing, since you want the address.
Yeah.
hmm And the next thing is you need to update the bucket index such that when you invoke increment the next time, it will not try the same uh, bucket which we just iterated through again, but will then start with the next bucket that there is. Nope.
Well, bucket index.
So what you would want to do is to set bucket index to the next entry in the array behind the entry which we currently have assigned to our current entry.
So I plus
Yes.
2,
No, I plus 1.
I plus 1. Okay, now
And we can return.
in the if already.
Yes.
Can I ask something?
Sure.
So why do we have to define mBucket index as I plus 1? Because I is defined as mBucket index. So why wouldn't it be correct if we write mBucket index plus 1?
Well,
Because
we
I thought
defined
it's
it
the same.
so we defined the I as bucket index, but then at the last section of the loop, we have the I plus plus, so we are starting to increment. So we go not by one bucket each time, but we can skip multiple buckets, and then we want our incrementation of our bucket index to reflect this. We don't want to go back on the list where we already checked certain entries.
Okay. So if we would write mBucket index plus 1, we always go one by another and don't skip the ones which are empty. Oh.
So if we have some empty, and let's say, let's write down a simple example. So let's say we have some list with which can contain
Which is a good
something or
question.
contain nothing. Oops. And then contain something and then again something and then maybe nothing and a few more times nothing and then something and then a few more times nothing. So let's say we are starting, we have something that points, I need to make this a comment. Then let's say we have something that points in here.
Mm-hmm.
And then, so this would be where our bucket index points. So we start with this entry. We check this entry, we see that it doesn't contain anything. So then we check the next entry. It still contains anything, so we can again make plus plus. We check this entry, it still doesn't contain anything. We again plus plus, and then we finally found something. And then from here we have a list, so we would be start listing whatever is inside. And if you then would increment your whole thing just by one I, then we would go from here to here.
Yeah.
And what then happens is we again try this one, nothing, this one, nothing, and then we try this one which we already have processed. So then we would list a part of the table again a second time, which we don't want. So what we need to do is we need to move this by as much as we need it to point to the next potential candidate. So technically the variable bucket index should be actually called next bucket index, basically, because it doesn't point to the current one, it always points to the next one we need to check. And in this case it points here. So we process this, then it points here, then we process this, then it will be pointing here, and then the same thing will happen as before. We see nothing, so we again increment a couple times until we find this. We found it, we will process it, and the pointer will then point here, at which point the thing will then go until the end and then see that it didn't find anything, and then that means that we have stepped through the whole thing.
Okay, I see. Thank you so much. That was
You're welcome.
explaining it really well.
And I see there is a bug. There should not be an else. This needs to be just a standalone. The reason for this is so if this here is fulfilled, so or differently. First case, this is not fulfilled, then we just execute this directly. If this is fulfilled, then we do this, and then we see if this is now true, then we just return, so we will never reach this part of the code anyways. But if this is not correct, then we still want to do this, so we don't want an else, we really want
That's why. Okay.
return if everything is fine, or then fall through to the next operation. And here it's the same thing. If we found something, we return, and if we didn't find something, now we are in the case end of table. And now we also need to set the entries appropriately. So we know already that current entry is null, so we just can leave it at null. This will be perfectly fine. But we should then set a bucket index to something that we will recognize as being outside of the valid range. So for example, bucket index we will set to bucket count, which indicates that there is nothing more in the table that can be processed. Okay, so we have this. So now I would say we go to the convenience functions, which we have. Yeah, to those. Well, let's start with the most important ones, which would be just here, these two. So how this works, you can just copy from the linked list implementation. With the appropriate adaptations, of course.
Why is this not matter?
They are both there, you can just copy both.
Why blind? Oh, there it is.
Just that we don't have p next, we have current entry. And I think we don't have data, but we called it value or something like that.
Yeah.
Okay. Then we need the is equals and is not equals functions. For convenience, I would just I quickly will do something here. Just return negation of is equal. Negation of is equals. That saves us from typing. And
that's neat. Nice.
Yes, and in this function we need to well compare if all the 4 variables are the same and return false if one of them is not. So one can copy the assignment operator and then just refactor it to make everything a comparison and put it in a if and return false if it's not true, and then a return true if all the checks passed.
Or we kind of compare this entire block inside
Yes.
an if, right? Yeah.
We cannot do the whole block. Well, you can compare them like by one if you concatenate them with the AND or operator.
Yeah.
And of course, then you will also need to change the equals to a double equals, and so on.
Thank you. Like this? Or do I not even need the else?
You don't need the else, but you can have it.
Okay. So it doesn't make a difference in this case.
It will not make a difference.
Does it make a difference computationally, actually? If you wanted to make speedy code, like, would you leave it away?
If you would have like a compiler from the 1980s, yes. If you are using any sort of modern compiler,
Okay.
it will be smart enough to leave it away on its
Okay.
own. The shortest way to write it would be just to not use the if at all, but just quickly.
With question marks or?
No, even simpler. Bam.
Oh.
And this also would be the most efficient way at the same time because it avoids any
Uh-huh.
branching entirely. So branching operations, well, you at least need to load a few more instructions to the CPU, so it's at a very small level marginally slower. But again, a good compiler would see this code either way written and still optimize it properly. So modern
Okay.
compilers are very sophisticated in this
Mhm.
sense. Okay, so we have this. So what we are missing is now the begin function that will make the whole thing work. And yeah, so you need to implement that. Basically both begin and end functions. And then we can test whether it is working.
So what exactly is begin supposed to do again?
Well, begin should initialize the whole thing such that when we then try to use, so basically begin needs to set the array to the array pointer, the index to the next index of a valid entry, the current index to the current entry to the first entry that there is, and the I think did I mention the array count? Well, all the 4 variables need to be set basically. So it needs to invoke the constructor. And we have here this complication that the first entry might not be a valid value. So what it should do, I think the simplest would be is to work like this. It first assigns just array pointer, array size, so array count I mean, and array index, and as index it would initially assign 0, and as a current entry it would also assign null. And then you just call increment, and increment will then initialize the whole thing, because since our definition of index is like the next value, so it takes the current one. You would use the assignment, sorry, the constructor, so you pass this as arguments to the constructor. So you can just write as iterator. Well, give it a name like I or something. Capital I usually. And then you assign the 4 values.
In these parentheses.
We're just calling it like a function.
Does it matter in which order I give the values? Or
Yes, of course. Otherwise, it
yes.
wouldn't know where to assign them.
Oh yeah, these.
You can write it down as a comment, for example, to know what to put where.
Now I set all of the what's the names? To 0. I set the index to 0.
You set the index to 0, but you send this as a argument inside the line 177 and not below it.
This is
but without the names, you just write comma 0. Yeah.
Oh yes, of course I'm not. So how do I know the count and the array, for example?
We have a variable m arrow, and it contains bucket count or something. Yeah, bucket count. buckets. Here null.
Um,
Right, then we invoke our increment function, i.increment, and you can return as iterator. Sorry, you can return I, just I. Okay, and then we need to define our end iterator.
do I also use the constructor?
Yeah. Just that as an index you specify not 0 but bucket count. And of course we won't increment anything, we just return the iterator as is. Okay. Yo, that should work. Let's make a test case.
Test case for operators.
Just somewhere where we already used the table. Then there we will just print all the entries. I think it should be on the end of the file. Yeah, instead of, so below my dump table, we just implement a for loop using the iterator to list all the entries. Yeah.
But I can't just write auto, right? Like we've done
You can write
before.
auto I is equals my table begin. Okay, let's run it. It's not happy. Yeah, because the T is not T, T is V for value. I'll quickly fix that. Okay, this should this will be value. Also, this does not return anything, so let's comment it out. Right, and this of course won't work because it doesn't know the type. We need to use the C string. Just format everything nicely. Is it not value? Should be value. I see the problem. This will be a problem. We need another asterisk here. So if you write a type and then a name, if you want the next thing to also be a pointer, it needs also to start with an asterisk.
Ah,
Wait, it doesn't like our. Yeah, sure. There is one equal sign missing. And okay, there is some. Let's see. Count asterisk size. Count buckets. That should be right. Bucket count. Why doesn't like bucket count? Size TS entry that looks. Wait. Have an array of pointers, not an array of entries. So bucket array is a double pointer. It's a pointer on a pointer, and entry should be fine. Okay, and here, right, if this is an array of pointers, then we don't dereference it, we just take the value where it is as it is. Index, there is a typo here.
another one.
Yes.
Sorry.
Well, it didn't crash, and it printed 2 entries, 3 entries, and we have 3 entries. So we are missing here some new line. Okay, great, it works. So the next thing we need, maybe this time from Miss Chiara, will be the find function. So the find function is somewhat similar to the begin function, just that instead of giving us something at the begin, it needs to find the entry inside our table and then return an iterator which would be pointing exactly to that particular entry. We have here a find function that already does something, but this will need to be copied because it does not maintain. No, actually, it doesn't even need to be copied. We can recover the index. So basically, what you would be doing is you are generating this index here, up there. Then you because we will need the index later. Then you can use the find pointer function as it is here, just to find the pointer. So you would start with calling find pointer with the key. You check whether the return value is null. If it is null, then you just return end. If it's not null, then you start constructing your iterator. You put here the value you got from find pointer, and you put here the index that you can compute or recompute using this make index. That is easy, and yeah, and the rest doesn't change. So it's quite a easy assignment comparatively. Yeah, so let's begin.
Yeah, I just connect address. Okay. That was it. Yeah. Okay, so shall I first of all copy that?
I would just copy the lines 226 and 228 because we'll need them. You can copy both in one go.
Yeah, sorry.
And the next step will be to call the function as is, so we don't need to copy anything more. We just want to use the function.
And so the find PTR function.
Yes, so we want to call the function and save the return value into a variable. The return value will have the type as entry asterisk.
Mhm. Mhm.
No, you just write the type, then asterisk, then the name of a variable, and then is equals find ptr. Just want to call the function.
Like this.
The asterisk comes after the type. And then you of course need to provide the argument. We just care for value. The second argument in this find the start, you can delete that. Is not needed right now. The whole thing until
Yeah.
including the comma.
Okay. As entry F find PTR.
I see another detail. This should be here have a k. Yeah, okay, now it's fine. We copied it from the other function and we had some things which we don't need. You can provide the key as an argument to find PTR.
Um, mm, mm, No, that's not correct, isn't it?
No, you need just key EY.
Yeah.
K needs to be
Okay.
lowercase, I think.
Yes. Well, or we actually should change the
Yeah.
key. We should change the key in the argument to be uppercase. Do it the other way
Well,
around.
yeah, true.
Fix it the other way around.
Yeah. So
It doesn't
shall I?
matter. You can leave it as is. Right. And now you just check if f is null, and if it is null, you return the result of the end function.
Mhm. Yeah. Mm.
hmm And if it's not null, then you will need to create an iterator which will be pointing to what we just have found.
Mm. Then we have Mhm. F is
You
it
don't
pointing to hash?
you don't really need the if around, because if the other condition is false, then we will return
Ah,
and not reach this portion anyways. In principle, what we want to do is to return an iterator um, like created in one of the upper functions, but instead of null ptr, we pass f, and instead of m arrow bucket count, we pass the index from line 192.
mm, yeah. Um, it's- so F is pointing, or F is
F is pointing to an entry in the bucket where it found it, and
mm-hmm.
this will be instead of null ptr inside the as iterator once you create it.
Ah, okay. So I have to create the uh, iterator.
You can copy the content of the end function and then just adjust the arguments of the
Ah, yeah.
iterator.
So then this is mm, mm, then we have next and is that correct?
Uh, it switched.
Ah, okay. So first F and then index.
Yes.
Okay.
And then you return it, and that should be it. Then we need a test case.
Return as iterator.
Just I, capital I.
Also. Mm.
The idea is that we just look for one of the values, let's say the value 456, and
Mhm.
want to print the associated string.
Okay. So actually like this line here.
Well, not quite. The way you use iterators is you first you get your iterator with find, then you compare it whether it's end or not, and if it's end, then you don't do anything, and if it's not end, then it's valid, and then you can print it.
Mm.
So just create a variable f and assign to it the result of my table find.
Mhm. So, mm.
It should be of the type, you can use the auto type. F is just auto F, because usually you would have C table, pointy bracket, what do we have then? Int, comma, C string A, another pointy bracket, double point, double point, double point. So a pair of double points as iterator. That would be your type for F, which is very unpleasant to write down. So you just use auto. And now in find, you can just specify one of the three values, either 1, 2, 3, or 5, 6, 4, 5, 6, or 7, 8, 9, whichever you like. Right, and then you can check with an if f is equals, or rather if f is not equals my table end. And you close bracket. And if that is the case, then you can print the iterator the same way as it was printed in line 228. Just that instead of f, instead of I, you are using f. Okay. One more bug. The return in line 231 should be the last thing in the function. So just move it to the end.
Shall I run it?
Yeah, you can run it. Yeah, click. Yeah, just make the K capital K in the argument, or like this. Yeah, that's also fine. Yeah, it worked. It printed the last line twice. We should maybe change to entry to found entry or something like that. It's just that we can tell them apart.
I can also
You can also add some spaces. Okay. Now, ideally, in a real world test case, you would want to make a second test case, like F2, but provide a number which is knowingly not contained within the table, just to check whether it then will correctly return end.
So for example, 0, 1, 2, something
For example,
like that.
yes, exactly. You just need to change F also in lines 238 and 39 and so on. No, not there. That's fine. Here. You cannot print it if it was not found. So if it's not found, 231, then you need to just write text entry not found without trying to get anything from F. And 238 also F2. Yeah, okay, let's run it. Yeah, that works perfectly. Okay, so let me have the mouse. Let's see. So this is done. If there is anything,
Quickly disconnect. Sorry.
yeah, if there is anything that one
So.
can quickly improve or comment on, I think. Right. So there's one thing we have forgotten to add. since this whole thing here is a table which also not only contains the value but also contains some keys, we would like to be able to obtain those keys from our iterator. So we just make a const k reference key, then we just return our key. So this is quite useful, and here thus we could extend this function to entry key double point space, and here go with key, and since key is an integer, that should work out of the box. Or not. One too many returns. Okay. So now it here writes the key value as well. Here we could add this, but it doesn't make any difference. It's just important to have this on our iterator, demonstrate that it works, because this is quite convenient to have to be able to, because then you really can replicate the whole functionality of dump table just by using the, basically we just did that. It's our test case here. When we compare it, we see that it now is really doing the same thing as dump table, just in a slightly different format. And while most of the iterators generally behave similarly across different platforms, so whether it's Qt or what's the other one, STL, then they allow you to reference the things with the content with an asterisk, or using the arrow operator if it was a complex object. But with regard to iterators for keyed container types like maps or tables, it is differently. There, for example, Qt is very nice. They have like a value function and a key function, like we did. Well, we didn't add a value function since we can access value with the asterisk, but we have our key function. This is quite nice, but in STL, what you get is what the iterator gives you is basically a reference to a STD pair, which then the first entry is the key and the second entry is the value. And this is a little bit inconvenient, I would say, because then it changes how you operate with this. And also it means that if you have some code, you cannot just replace a Qt map, a QMap, with a STD map. The way the iterators work there will be inconsistent. So this is something to keep in mind. Our own type again won't be consistent, won't be directly compatible with either. Although with Qt, if the Qt thing is written the right way, it would be, since the only thing we are missing here is a value function, which we also could add. So if we would want to be fully Qt compatible, we just add value, and then it behaves like a iterator from a QMap or a Q table, Q hash table. Okay, I think we are at the end of the exercises. We are running out of time anyway, so we'll see each other for the lecture in a few hours, and yeah, and that's that.